Hey everyone, welcome back. For today we are doing day 11, two-dimensional arrays. For this question, we are building on top of our knowledge of one-dimensional arrays or lists in Python by adding another dimension. For this question, we're given a 6x6 two-dimensional array, and that is alias as A. And we define an hourglass in A to be this 3x3 grid, which consists of one row, two rows, but only the center element in the second row is accounted for, and the final row right here. And in this case, there's only 16 hourglasses in A. And the reason is, if we take the top left corner cell of the hourglass to be the pivot, notice that if you move this pivot point to here on the fourth column, notice that the hourglass would already be occupying the edge of A. If we move this pivot towards the right over here, your hourglass will be out of bounds, so that will not be valid. So similarly, if you try to move this pivot all the way to the fourth row over here, similarly the hourglass would already be at the edge of A, and moving it down one cell further would cause your hourglass to be out of bounds as well. So in summary, the only valid hourglass cells that we have, the pivots that we have, are these 4x4 cells over here. And because of that, we only have 16 hourglasses. So for this task, we have to calculate the hourglass sum for every single hourglass that we have in A, and also print out the maximum hourglass sum. So for example, if your hourglass is this first 3x3 grid over here at the top left corner of A, the hourglass sum will be 7, because we will be adding in these 3 elements followed by this and this. So we will get back 7. For the input, we have 6 lines of input, and every single line consists of 6 numbers, of which there are 6 columns for every single line. And we have to print out the maximum hourglass sum in A for the output. Notice that for every single cell in this 6x6A, notice that the value range from -9 to 9. So what this means is, the lowest that your maximum hourglass sum can be is actually -9 multiplied by 7, which is -63. So if we are using a variable to keep track of the maximum hourglass sum, please remember to assign that to at least -63. So this is how your hourglasses will look like. It's pretty much the same explanation that we had earlier. But if you like, please take a look at each of these hourglasses to better understand how the hourglasses are obtained. And with that, we are ready to start implementing for this question. Before we start, let's go through the input function used to pass the 6 lines of input into array on line 13. And this is all auto-generated by HackerRank. So to better understand it, let's start from here. First, HackerRank defined on line 15 a simple range function, a for loop over a range of 6. In other words, they are doing it 6 times. And every time when they see a line, they would read in that whole line with the input function, strip it of empty spaces or new line characters on the right, and split it by an empty space to get back a list of string of size 6. And once that is done, they decide to use the map function to cast each string inside that list into an integer, giving back a lazy map object that consists of their integers under the hood. Once that is done, HackerRank decides to evaluate this map object, and we get a list of integers. This list of integers is then appended into array on line 13, and line 13 is really of type list of integers. To make it clearer, I'm going to import the list type from the typing library and give line 13 a type signature of a list of an integer. And at this point, we understand how HackerRank read in the input, and we are ready to start implementing for this problem. This challenge can be broken down into 2 steps. The first step is for every single pivot point that we iterate in this 4x4 grid over here, we're supposed to pass the hourglass for each of these pivots. And that's the first one. The second challenge would be to take in this 3x3 hourglass and return back the sum for that hourglass. So before we start, I'll be starting off with the implementation for getting the sum of an hourglass first. So I'll be defining a function on line 11. I'm going to call this getHourglassSum. And this would take in an hourglass of type list of integer. And this will return back an integer. This will take in a 3x3, take in a 3x3 hourglass, returns our hourglass sum. And to do that, we will be doing a cell iteration across the 3x3 grid of the hourglass. So for row in range 3 and for column in range 3, the first thing that we would check is whether if the row happens to be 0 or 2. And that means if the row happens to be the first row or the third row. So if the row happens to be the first row or the third row, then we'll be using every single value in each of those rows for the hourglass sum. Let's define the hourglass sum variable on line 15. Let's set this to 0 first. And if that is the case, if the row happens to be the first or a third row, then we will add every single element inside that row. So row, column, like this. If it happens to be the second row, then we would check whether if the column happens to be the center one, which is this one right here. If that's the case, then we would add that center column on the middle row. And once that is done, we are finally done with implementing the hourglass sum function. So that's pretty much it. Now, to sanity check this function, let's get the first hourglass for this. If the pivot is here, let's get this 3x3 grid and try to pass it into this function that we just implemented. So we will have to figure out how do we extract the 3x3 grid from this 6x6 grid. So to do that, let's first implement the hourglass variable. This would contain the 3x3 grid that we want. So once done, we can iterate through the first 3 rows of this 6x6 two-dimensional array. So for row in array, let's do an array slicing like this. And the next thing is we can get the corresponding sliced row. This will be a list of integers. This would be row, first 3 columns. And once we're done, we can append this sliced row into this hourglass. To sanity check this, we'll be printing out this first hourglass, and let's see if we get 111, 010, 111. And you can see that is the case, and we managed to get the hourglass correctly. However, as you can see, like that's 3 lines right there. There is a way for us to combine these 3 lines into line 32 with a nice new syntactical sugar tactic called list comprehensions. So you are able to put all the results of these transformations directly into this outer list right here. And it looks something like this. For row in row, for row in array, like this. And just like this, we managed to get the first 3 rows into this hourglass outer list right here. And because we also want every single row to only contain the first 3 columns, we can also do the array slicing right here. And let's remove this to test out this list comprehension implementation. And as you can see, we managed to get the hourglass 3x3 grid as well. So once done, we are ready to test out whether if we get a 7 for this corresponding hourglass. Let's pass this hourglass that we just obtained into this newly implemented get hourglass sum, and let's check whether if this hourglass sum happens to be 7. So it is 7, so we got this implementation right. So now we are ready to start iterating through every single pivot points for this 6x6 array. So let's get to it. So let's delete this. And just as a reference, I'm going to comment this out because we'll be using this same logic to get each of the hourglasses for each of these pivot points. So now, before we start, let's define some convenience variables. The maximum rows that we have, this would be the length of array. This is really 6 because if you do a length of array, that's going to give you the count of all rows that we have. But because we are only going to iterate until the 4th row, we're going to subtract this by 2. And we're going to do the same for the columns. In this case, the maximum columns would be, we can just take it as the length of the first row. And in this case, we can do that by doing array first row and calling length on it. And because similarly in this case, we only wish to iterate the first 4 rows, I'll be subtracting this by 2. And once done, we're ready to start iterating through the 4 pivot points, the 4x4 grid of pivot points. So for row in range max rows, and for column in range max columns, we can start getting the hourglass, which is a list of an integer for this pivot. So let's use the list comprehension technique as we seen just now. So for row in array, in this case, notice that for this given row, this would be row plus 3, and in this case we will be getting the current column till 3 columns later, exclusive of the third column. So once we are done, we should get back the hourglass for this corresponding pivot. Let's run this code just to do a sanity check to ensure that we are getting all the hourglasses correctly. Notice that the first hourglass is correct. It corresponds to this 3x3 grid at the top left corner of your 6x6. And let's check the bottom right as well. So in this case, the bottom right hourglasses should be 440, 202, and 240. So 200, 240. Yep, looks great. So once that is done, we can start getting the hourglass sum. So hourglass sum would just be equals to get hourglass sum for this hourglass. And we can now define a new variable. Let's define this as max hourglass sum. This max hourglass sum will be used to keep track of the current maximum hourglass sum that we have. Notice that we set it to -63 because that is exactly the lowest the hourglass sum can be. Every single cell can be as low as -9. So the lowest is -9 multiplied by 7. So that gives us -63. So once we are done, we will just set max hourglass sum to be the max of itself, as well as the current hourglass sum that we have. So once that is done, we have successfully obtained the maximum hourglass sum. Let's print this. And we passed all the sample test cases. And we passed all of the test cases. So in summary, we went through how do we read in all 6 lines of input by analyzing HackerRank's pre-generated code, and how we started to break down this problem into 2 steps. The first step is to get the hourglass for every single pivot point. And the second step is to implement a function that takes in the hourglass and give back the hourglass sum for that 3x3 grid. And once that is done, we created a variable to keep track of the maximum hourglass sum and just update it as we go through every single hourglass that we found. So that's pretty much it for this question. If you were curious, let's break this down and analyze its time and space complexity. If we take n to be the size of A, so to be more specific, if n is the row or column size of A, then in this case, notice that because we are currently iterating through every single row and column of this n by n A, your time complexity is going to be O(n) times n. But we are not done yet. For every single iteration that we go through over here, we are also doing a get hourglass sum on each of these hourglasses. So what this also means is we are also doing a computation here. And if we assign m to be the row or column of the hourglass, then for every single cell, the n times n cells that we have, we are also iterating through the hourglass, right? So in this case, this would be m times m. So the time complexity is really n times m multiplied by m times m. So for the space complexity in this case, notice that over here, we are currently initializing a copy of the hourglass that we found. And in this case, this would take m times m. So the space complexity will be O(m) times m. And when we read in the input, we also saved all of the cells over here of size n times n into line 34 as well. So if that's the case, the space complexity will be n times n plus m times m. So it's pretty much the memory used on line 34, as well as the temporary variable on line 47, which is consistently mutated and changed to a new hourglass as we iterate through each of the hourglasses. So in summary, it's pretty much n times m plus m times m. So that's pretty much it for this question. It might have been quite convoluted, but I hope that this was this was a decent explanation. And if you found this video to be of value to you, please give us a like and subscribe, and we will see you in the next video.